Okay, so today we're going to talk about arithmetic and geometric series. So it says here, find the sum means to add up, of the first 8 terms, and here's my sequence so far, 1, 3, 5, 7. So notice that my sequence is going up by 2, so the next number, I need 8 terms, I have 4 so far, I need 4 more. So the next number would be 9. And then 11, 13, and then 15. So there's my 8 terms, so I want to find the sum. So I take all the numbers, 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15, and I add them up. So the sum of my numbers, the sum of my arithmetic sequence is 64. Okay, find the sum of the first 5 terms. So I don't have my terms. I have a formula here. A sub n equals 3 times 1.1 raised to the n minus 1 power. I need the first 5 terms. So I'm going to start with a sub 1 being my first term, a sub 1. So it's 3 times 1.1 raised to the 1 minus 1 power, which is 0. So it's 3 times 1.1 to the 0 power, and that's equal to 3. Now I need a sub 2, my second term. 3 times 1.1 raised to the 2 minus 1 power. So it's 3 times 1.1 raised to the first power, which is equal to 3.3. A sub 3, the third term. 3 times 1.1 raised to the 3 minus 1. So that's 3 times 1.1 raised to the second power, which is 3.63. A sub 4 is 3 times 1.1 raised to the 4 minus 1. So that's 3 times 1.1 raised to the third power, which is equal to 3.993. And my last term, a sub 5, is 3 times 1.1 raised to the 5 minus 1 is 3 times 1.1 raised to the fourth, which is equal to 4.3923. All right, you add them up. And when you add them up, you get 18.3153. So this was a geometric sequence that we added up, and I got 18.3153. So what these are called, this first one, since I'm adding the sum of numbers that are increasing by adding 2, that's an arithmetic series. And the second one, which I have a common ratio, right? My common ratio is 1.1. And that is the sum of a geometric series. All right, so let's see what it says down here. Get rid of this. Okay, so it says the arithmetic series. To find the sum of an arithmetic series. All right, now, this formula is not on the formula sheet. So the formula for an arithmetic series is S sub n is equal to, so it's equal to n so it's n times a sub 1 plus a sub n divided by 2. Okay, so this is the formula to find the sum of an arithmetic sequence. So if I knew this formula before, I could have used this formula for number 1 to add up those 8 terms. So clearly you don't have to use the formula. You could sit there and write out all the terms and then add them up. But if it's a whole bunch of terms, sometimes it's just easier if you know the formula. However, this particular formula is not on your reference sheet when you take your regions. So you would have to memorize this formula. I'll tell you what most kids usually do when a question like this is on the regions. They usually just write out the numbers and just add up the numbers. Even if it's 50 numbers, they usually just write out the 50 number sequence, and then we'll take all those numbers and add them up. And usually kids are very successful with that. Okay, so now let's just talk about this formula. So S sub n, this guy here, what that means, that represents the sum of n terms. N is the number of terms you're adding up. So if you're adding up 8 terms, n would be 8. A sub 1 obviously is the first term. And A sub n is the nth term. So if you're adding up 8 terms, then it would be A sub n. So you do need that 8th term. You need that last term. Okay, so remember, this is for an arithmetic series. That's for when you're adding or subtracting a constant to go from one term to the next term to the next term. And remember, that is not on your reference sheet. All right, let's talk about the geometric series here. So a geometric series is to find the sum of a finite geometric sequence. Okay, so here's the formula. So it looks kind of like the other one, just a little bit different. All right, so we have A sub n. That is the sum of n terms. So if you're adding up 8 terms, it would be S sub n. We could see here we have A sub 1 over here, so we use that twice. That's the first term. And we have R. Remember, R is your common ratio, which makes sense because it's geometric. And that's also in the denominator here, common ratio. And what else we have here is n, and that's how many terms you're adding up. So if you're adding up 8 terms, like this first one would be, over here would be S sub n, then n would be the number of terms you're adding up. So it's how many number of terms adding up. Okay, so this formula is on the reference sheet. Okay, so this formula you would not have to memorize. Okay, so let's take a look at, and of course, this formula too, if you don't want to use the formula, you could just, continue a sequence. If you're multiplying by 3, you need 8 numbers, just keep multiplying by 3 and then add the numbers up. You could do that too. That's fine. All right, so let's take a look at the first example. It says, find the sum of the first 5 terms if A sub 1 is 3 and R, so it's common ratio, that's geometric, is 2. So could we do this? Could I do, all right, the first term is 3. I'm going to multiply by 2 because that's my common ratio. So I multiply by 2, I get 6. And then the next number would be 12, and then 24, and then 48. Could I then now add these up and get my answer? Of course we could add them up and get our answer. My answer is going to be 93. But we want to practice using the formula. So let's write down the formula. It's S sub n. This is for geometric, and we know it's geometric because they give us R, the common ratio. S sub n, I'll fill in everything in a minute. I'm just writing down the formula. A sub 1 minus A sub 1 times R raised to the n power, all over 1 minus R. All right, so I have S sub n equals, it's S sub 5 because I'm adding up 5 terms. So it's S sub 5 equals A sub 1, which is 3, minus 3 times my common ratio, which is 2, raised to the n power, which is 5, all over 1 minus my R, which is 2. So the first thing I want you to do is I want you to evaluate the numerator. So we evaluate this first, and we get negative 93. And we evaluate the denominator, which is negative 1. So negative 93 over negative 1 is positive 93. Sorry, I'm changing colors because I was trying to find a color that would show up, and those purples aren't showing up. So you get positive 93 like I did before when I wrote it out and added them up. Okay, and let's take a look at the last one, number 2. A population of ants is growing. A population of ants is growing at a rate of 8% a year. If there are 160 ants in the initial population, find the total number of ants to the nearest whole number after 6 years. Okay, so that's y equals, so this is a growth problem. So this is a population growth. So remember that formula, it's y equals the initial amount, so we'll use P or A, doesn't matter. The initial amount, I think we use actually y sub 0, so let me get rid of this. So it's y equals y sub 0, that's the initial amount, times 1 plus minus your rate raised to the t power. In this case, I'll just use x. We could use t, right, to the t power. All right, so it's y equals my initial amount. My initial amount is 160 ants, times 1 plus my rate because it's growth. My year is my increase is 8%, so that's 0.08 raised to the t power. And in this case, I'm going to just put t. This is my formula. So I'm going to have y equals 160 times 1.08 raised to the 6th power because I went in after 6 years. So y is equal to 254. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.